Yep, so welcome again to my YouTube channel. Today, welcome to my math video, and today we'll be learning how to prove the method of solving the roots of a quadratic equation. We all know that there are two methods of solving the roots. So one is factorization, which is basically middle term splitting, and one is and another method is Sri Dharacharya's method. So this method basically states, this method is a formula, right? So you sometimes can get perplexed by middle term splitting, so then you can always apply this formula to find the roots of your quadratic equation. So a quadratic equation has two roots because this is a degree 2. We'll be also knowing why it has two roots. So there's a difference between quadratic equations and functions. You can also write this as a function. Okay, so let's just begin. So we need to prove this particular formula, which is Sri Dharacharya's method. Okay, so how do we prove it? So at first I just divided this whole equation including the 0 by a. You must be wondering why. It's because I had to just cancel this a. You would be saying, why not b or why not c? Because in this case a has this limitation. A cannot be equal to 0. So right, a can always be divided. A can always divide this equation because it's not a 0. If it's a 0, it won't be possible. B or c can be 0, right? So I would rather not take b or c. So we should always take a because we would cancel this a, and of course a cannot be 0, right? So the next method is, so we get this, but then you would notice that x squared plus b by a times x is very close to this algebraic identity, which is a plus b whole square. So how to do it? So we are almost like we are very close to that identity. So we just multiply a and x by 2 so that we can get 2ab, right? So 2 times x, which is in this case here, times b by 2a. So we get this. We get b by 2a plus we whole square this. We whole square b by 2a so that this equation, this algebraic identity gets completed. So then this would become this, which is x plus b by 2a whole square. But then this whole equation changes when we add b by 2a whole squared. So we just subtract it by itself. And plus c by a as usually is equal to 0. So now the next method is that, of course, we do this, we whole square it, we just simplify it. But then now there are many ways of solving it. But the most easiest and the way which is common also and which I would prefer to use is this, that we would just whole square this whole term, which would be b squared by 4a squared minus ca, and this would give us this particular result. We'll factorize the a's because see the a's are common, right? So the a's will be out, and then it would become a brackets b squared minus 4ac. Now a and 4a cubed would be divided. It would give us a result which is this. Okay, so now what we get is that x plus b by 2a whole squared is equal to this, right? But now we should always be close to victory, to our ambition. So in this case our ambition is to solve this, to prove this, right? So we just take the square root of this this identity, and of course if we square it then it would become x plus b by 2a, right? So if we square this out, this thing, then it will become plus minus square root of blah blah blah. Why plus minus? Of course, because a number when square rooted will give us a result of like two numbers, numbers which are negative and positive both, right? Because negative whole squared is also positive, positive whole squared is also positive, right? This would give us basically two answers. One is square root of this, one is the negative part, one is the positive part, right? So yeah, just simplify it further. This is whole. I mean, so we square this out first, which becomes 2a, and we square this. We don't know the value, but we don't need to completely square this out. We won't be able to, but then okay. So yeah, so now we subtract. I mean, we take this to the RHS. This becomes minus b by 2a plus this particular thing. 2 is common, so this comes as a result, which is x, and hence proved. Right? This, my work is always very disorganized. Sorry for that, but then yeah. So people who are interested in add maths class 8 or 9, people who are actually doing maths and who are facing difficulties in proving this in class 10, probably you should be knowing this by when you're in class 10, right? So this is the proof, the most commonly used proof with reasons. And yeah, that's it for today.